Okay, so we have the panel session from the session before the coffee break with Abdul, Rahim, Nizamani, Nivel, and Persson. If any co-authors want to join, that's good as well. Does anyone have any questions?
I have a question to Patrick. It's about distinguishing correlation and causation. So one way to approach it is to use active learning and see which implications can be disrupted by actions. But then the NAS system might have problems with distinguishing the old belief from the new one. Both beliefs can compete for evidence, and ideally we would want to derive more specific beliefs and overshadow the old belief, forget it, but the old belief will also gain evidence from new observations. So how do you think it would work out?
Oh, okay. It's whether a concept takes the lead in priority level over another concept is very context dependent. And this priority budget plays an important role in distinguishing correlation from causation. For example, if we consider that there is a door and I want to go to the other side of the door, and I can do this by going to the door, opening it and going through, and then I observe I'm on the other side. But interestingly, I will never observe a person going through the door which is closed and then being on the other side. So always when a person goes through the door, either the door was already opened or one has to open it. This means in distinguishing between correlation and causation, now there needs to be another mechanism, because the system could assume that if the door is closed, it could assume that it's sufficient to just walk through, but then anticipation kicks in. The system walks against the door under the wrong belief, that predicted belief that it will be on the other side. But this will not happen. The predicted event that it will observe itself on the other side of the door won't happen, and so the system will form a negative belief which will revise this hypothesis. Then suddenly the hypothesis that the door at first needs to be opened and then it can go through will take the lead. And this is an example where wrong temporal beliefs are corrected. And then there could be a more detailed belief, a more complex one, which would, for example, say, I can only get to the other side in two different cases. Either the door is open and I can go through, or I need to open it before. And that's it.
Thank you.
Are there more questions?
My question is for Eric. You refer to your system as running in continuous time, meaning being asynchronous, and you say there are no time steps. In fact, you said it even more emphatically when you said, if it needs to ask the question what to do next, the system fails. I'm just wondering if you can elaborate on that, given the fact that I assume your system runs on a classic computer architecture of classic hardware and an operating system, etc., where that time is typically managed in time steps, I thought.
Yeah, I refer to the time steps as commonly used in real reinforcement learning, for example, or research. All of these domains in AI, when time is not taken at the core of the knowledge. You know? So classical planning does it in this way. At the time T, I do this, then at the next step, what do I do? And search means the predictions are blocked. The whole world can explode, but the time it takes to compute a plan is not taken into action. The time is only seen as an external factor. It has no subjective representation. By subjective representation, and it's a necessity for the system to roll in its planning the time it takes to plan. It's not just a question of the next time, or the next step. There actually is no steps at all.
Do you need to know the amount of time required to execute each model within your whole system?
Well, actually, this time is known in advance.
And how do you know that in advance? How can you predict that time? Is it the same for all models?
Yes. All computation times or worst case execution times are bounded by a constant. Each in inference takes exactly the same time as any other. The scheduling time is bounded, the eraser time is bounded, the writer time is also bounded, the memory is fixed, so then we are in a sweet spot there.
Thank you.
Any more questions? You guys are all sort of doing similar-ish things. Do you have questions for each other? Well, maybe the audience thinks it's interesting. Okay, so why do we need to make things so difficult and consider the fact that time is bounded? I mean, it is, but just what happens if you just let your architecture run? It will run out of time and we'll make a decision that's not completely optimal, but you'll never get it anyway. Can you explain why that's bad? Why you need to explicitly think about how why the system needs to explicitly think about how its own resources are limited, bounded. I mean, all of you.
I didn't get your question. I'll talk to Eric.
All right. Yes, in our case, yes, the system builds models of its own resource expenditures. Such models are have exactly the same form and semantics than any other that the machine has observed in the world. There is no real distinction between the outer world and the inner world. So this helps, this produces prediction of the resource expenditure and allows the system to take proactive actions, meaning to delete the least valuable things. So it is the way we avoid the catastrophic forgetting.
Do you have a comment?
Yes, one comment, namely that in a natural situation, we also observe this in ourselves. Often when we need to take an action in short time, for example, I traveled to Berlin and there was a train coming and I had to decide, does it go into the right direction? And there was the map, and I needed to consider, I need to go to the west. And so I considered this at first and was trying to get all my thinking resources into the right direction in order to be able to get into the train and to decide whether it's going into the right direction. So I used my mental resources as good as I was ever do.
Okay. Has anyone come up with a question yet? Here?
I have a follow-up question.
Sure.
So I have a follow-up question about NAS. It appears to me that the more complex belief that you form that involves the action might initially have low confidence because it might be derived by abduction. So it will lose with the old belief, which accumulated a lot of evidence, the more general belief. And following that, the new evidence from observation will still favor the general belief. So how come we will progress to the more specific beliefs so that they how to kill the general belief in NAPS?
I think I understand the dilemma. What we think is that, for example, perception is not always starting at the atomic events, but sometimes it might be, for example, I've worked out an example where numbers are put in, and these numbers share an abstract property. For example, I only put in even numbers to the system. Each number is different, but shares a common structure, namely to be even. And interestingly, by the design of the concepts, it's that way that, of course, this pattern, which is reobserved all the way, will gain the budget lead in memory in the system over the specific perceptions, namely the numbers which were observed. So it can happen that, so it's not, in NAS it's not always the most specific concepts which guide the attention of the system. It might be that there is a certain more abstract pattern inherent in all the current input which may take the lead. So attention can be guided by concepts of different levels of description.
I think I could maybe jump into it, because I'm not sure, because you've asked the same question twice in different ways, basically. I don't know, Patrick's probably trying to answer it, but he's missing it. You were saying if there's a general belief in the system, and then you receive an event that's the same statement, but it's a different level of confidence, for example. So you've got a high level belief and then maybe you have a low level event coming in. Which one takes precedence? Well, in fact, they actually merge. They're revised together and you form a new general belief based on the event. So is that what you're trying to get at?
Yes, but the specific belief contradicts the general belief. Since the specific belief contradicts the general belief.
That's fine, because the system it supports contradictory beliefs, and they could be completely opposite each other. The revision process allows contradiction, and if there's one very positive and one very negative, then they will, based on the amount of evidence available, they will kind of meet somewhere in the middle. Yeah. Okay.
Okay. If there are no more questions, then let's thank the panel again.